Yeah, we have this other simulations, interactive web application simulations that are coming up. I'll put the links. We have another simulation coming up around the penile dysfunction. We had an older version of it. Looks like that. But we also have a newer version that so we had the code originally made by a simpler model, and then we had a more advanced model looking at it as well. So now we have to essentially just choose which one we like better. It could change the background color and the angle for, this function there. Could be made better so it doesn't actually do that thing. And we have this function slider. Obviously, this meant to be highly scientific and all. So yeah, we'll be adding references and the like, doing cross section, and doing particles. 48 particles. Sounds a bit weird. A minor dysfunction. Number of particles 42. I could barely see it because of the white background. We can have a more advanced model looking at this. Let's chat to... Well, first of all, yes, we do want that version because it is better than the previous one. So keep that file. So that will be just index HTML. Can you do a quick conversational response? Make it interesting and fun. You can address the listener directly. So first person, and just explain what this web application does, but not in technical terms, just in, so technically, but without any terminology. It's a different model, so the voice would not be as
Absolutely.
nice as before.
Here's a fun, conversational explanation. Hey there. So, you've just opened up a super cool interactive tool that lets you explore how the human body works, specifically, how certain parts do their thing. You can press buttons to see what happens during different moments, like when things get excited, when nature calls, or when you want to reset everything back to normal. There's even a slider to see what changes if things aren't working perfectly. You'll see everything move and react right on the screen, and if you want, you can turn on sound for a little extra flair. Basically, it's like a hands-on science demo, but way more fun and visual. Go ahead, poke around and see what happens.
Can you see any issues with the styling of the page, particularly the colors, specifically the colors of the simulation colors, of the simulation canvas?
Here are some observations about the simulation canvas colors based on your HTML and CSS.
Okay, just looking at the specific file, can you do a conversational summary of any issues with the styling, the colors on the page, the canvas?
Sure. Here's a conversational summary of the color styling issues you might notice on this page. So, when you look at the simulation, most things are pretty easy on the eyes. The background is a gentle off-white, and the controls pop with blue and pink. But once you get to the simulation canvas, some of the colors for the anatomical regions are pretty close together. For example, the shaft and glands are both shades of pink, and the cavernosa and spongiosum are both reddish, so they can blend together a bit, especially if you're not looking closely or if you have trouble distinguishing colors. The urethra is gray, which stands out, but the bladder and testicle are both pastel, so they might not be super distinct either. If you're using dark mode on your system, the white canvas might feel a little stark compared to the rest of the page.
Can we keep the whole page as is, but just change the the canvas background, make it dark?
The canvas background is now set to a dark color, while the rest of your page remains unchanged. If you want to adjust the shade further, just let me know.
Okay, can we look at the angle? So when we press the urination button, it's currently too close to the edge of the canvas. Can you explain that in proper language, just in continuous language, conversational response?
Certainly. In your simulation, when you press the urination button, the shaft's angle is determined by the current arousal level and dysfunction state. For a flaccid, non-aroused state, the angle is set to point downward, 90 degrees, which can cause the tip of the shaft to be positioned very close to the bottom edge of the canvas. This means that when urine particles are spawned, they may appear almost at the edge or even partially outside the visible area, making the visualization less clear and potentially clipping the animation.
So wait a second. So we're talking about the normal state, so not aroused, and we're talking about urination. So how would you change the animation, the angle of the simulation, so the urination looks better?
To improve the urination animation in the normal, flaccid, not aroused state, you should adjust the shaft's angle so the tip is not so close to the bottom edge of the canvas. This will make the urine particles more visible and prevent them from spawning at or near the canvas boundary.
Okay, still. So fix the angle supposedly. Shall we redo the code with GPT-5 just as a single shot? I don't know. So we have this version. It's working okay. Or should we continue with the basic model? At the bottom of the page, can we add a detailed section about future directions? What can be improved and made better, and how do we make this animation simulation more scientifically accurate and more useful?
This interactive simulation offers a comprehensive and engaging way to learn about the anatomy and physiological functions of the human penis. It is designed to help users understand key biological processes such as urination, erection, and ejaculation through hands-on exploration. By using the simulation controls, users can observe how various factors, including erectile dysfunction, impact both the structure and function of the penis. The simulation features real-time visualizations, dynamic sound effects, and a debug panel that provides deeper insights into the system's internal state. This tool is intended for educational use, aiming to make the study of human anatomy and physiology both accessible and interactive. How it works. The simulation allows users to interactively explore the anatomy and physiological mechanisms of the penis. Here are the main features and functionalities. Arousal/erection *. The simulation models blood flow into the corpora cavernosa and corpus spongiosum, which leads to changes in rigidity and angle of the penis. Users can adjust the severity of erectile dysfunction, which dynamically alters these anatomical responses. Urination * users can trigger a realistic visualization of urine flow from the bladder through the urethra. This process is depicted using particle effects and accompanied by authentic sound effects. Ejaculation * when the simulation is in an aroused state, users can initiate semen ejection. This is represented by bursts of particles, visually demonstrating the physiological process of ejaculation. Reset * the simulation can be reset to its baseline, flaccid, state, clearing all particles and restoring anatomical properties to their default values. Sound * audio feedback can be toggled on or off. When enabled, users hear realistic sounds for events such as arousal, urination, and ejaculation, powered by the Web Audio API. Dysfunction slider * this control lets users adjust the severity of erectile dysfunction, which affects the rigidity, angle, and responsiveness of the simulation. Debug panel * the debug panel displays real-time information about the simulation's internal state, including arousal level, particle count, and sound status. To explore these features, use the controls provided above the simulation area. Observe how different physiological processes are represented both visually and audibly as you interact with the tool. About the tunica albuginea. The tunica albuginea is a strong, fibrous layer that surrounds the corpora cavernosa. Its structural properties play a crucial role in determining penile rigidity and the quality of erections. About the glans gradient. The glans gradient describes the gradual transition in color and texture from the shaft to the glans, head, of the penis. The simulation includes a slider that allows users to adjust and visualize these anatomical differences. Future directions. The simulation is continually being developed to improve scientific accuracy, educational value, and overall functionality. Planned enhancements include scientific accuracy *, adding more detailed anatomical models and simulating additional physiological processes, such as vascular dynamics and neural signaling.
We'll just leave it as is. We will just leave it as is unless there's any specific complaints. But yeah, it was a GPT-5 mini preview. Can try a different model. Should we give it to the proper GPT-5? It's not bad. Undo. Anyhow, we will leave it for now. Yeah, I'll do the other apps. Yeah, obviously redesigning stuff from scratch works much better. So yeah, we'll keep things as they are. We'll publish them on the website. Well, I mean, they're already published, which is the... I'll put a link on the landing page as well. And we will go from there and go check out the site. Let me know if there's any questions. And I'll see you next time. Don't forget to smash that like button. Does it look like a like? Well, it should, because it is. Bye.